Okay, on to the next part of today's lecture. We're going to talk about game theory. Game theory, I'm not going to bother defining, but basically, or at least not defined on the board, game theory is the mathematical analysis of decision making when there are multiple parties involved in the decision making processes. And this applies very well to oligopolies. If we think about the last example we did, where there are two gas stations, what the other gas station does affects my decision. So my decision that I make is dependent on what I think the other one is going to do. You can see why this would be called game theory, because it's very much like a game. And in fact, we use this in games all the time. So if you think about a game like poker, the decision to bluff is based on what you think the opponent is going to do. In basketball, the decision to run a pick and roll is dependent on whether or not you think the defense is going to be prepared for that offensive strategy that you're employing. So game theory is basically the study of these types of decisions. It's a big field in economics. If you go to grad school, you might decide you're going to focus on macroeconomics or microeconomics, but you can actually decide you're just going to focus on game theory. It's a big field. We use it for a lot of things, okay? And we're going to be talking about here examples in oligopolies. So I'm starting with this example here. Not a terribly interesting example, but we need to start with the basics. And so what we have here is two people, Ansley and Bailey. They're both about to take a test, and they're deciding whether or not they're going to study. The professor in this case doesn't grade on a curve or anything, so it doesn't really matter what the other person gets. So if you're Ansley, the grade you earn doesn't depend on what Bailey does. Okay, you can see. That's not typically going to be the case when we do game theory. In most cases, you really care about what the competitor does. So let's think about what each of these would do. Okay, they don't know what the other is going to do. So they don't know what their opponent, if you will, is going to do. And so they're making choices subject to uncertainty, subject to the fact that they don't know what their competitor is going to do. All right. So if you are Ansley, you can sort of read it this way. You can study, or you can choose not to study. All right. So study or don't study. If Ansley studies and Bailey also studies, Ansley will get an 85 on the exam. That's the way you read this. Okay. So if Ansley decides to study, there's two possibilities now. Bailey either chooses to study or not study. And in this case, in either scenario, Ansley is going to get an 85. Conversely, Ansley might decide to not study, all right, which gives these options here. If Ansley doesn't study and Bailey does study, Ansley will get a 45 and Bailey will get a 90. And if Ansley doesn't study and Bailey also doesn't study, then Ansley will get a 45 and Bailey will get a 60. Okay? So the decision to study or not in this case isn't really dependent on what the other one does. But you can imagine that there are four possible outcomes. They could both study, neither study, or one of the other two combinations where one studies and the other one doesn't. Okay? So what we would do now is try to figure out, are there any dominant strategies? A dominant strategy is the clearly preferred choice. All right, it's the clearly preferred choice regardless of the opponent's choice. All right, so if you're the Georgia Tech football team, and you don't pass the ball very often, running might always be the best choice. You may decide to run the ball virtually every play of the game. It might literally be a dominant strategy. But in most cases in football, there are no dominant strategies, right? Because what happens if you're running the ball all the time? Well, the defense will be prepared for it, which thus makes throwing the ball more advantageous. So you have that competition between you and the competitor. All right, so a dominant strategy would occur if there's a choice that you're going to make regardless of what the other one does. So let's look at it here. If you're Ansley, you don't know what Bailey's going to do. If Bailey studies, all right, which should you do? If Bailey chooses to study, what should Ansley do? If Ansley only cares about her grade, she could get an 85 by studying or a 45 by not studying. All right, so what that tells us is, if Bailey studies, Ansley should study. Okay? Now that alone doesn't mean that there is a dominant strategy. That just tells us what she will do in the scenario where Bailey decides to study. We got to make sure that this is going to be true in either case. So what if Bailey doesn't study? All right? If Bailey doesn't study, Ansley would get an 85 by studying or a 45 by not studying. So it turns out if Bailey doesn't study, Ansley should study. And so thus, what we have here is a dominant strategy. Ansley is going to study regardless of the choice that Bailey makes. So that is called a dominant strategy. All right? So that's what Ansley's going to do. She's going to study. Now let's think about Bailey. All right? You kind of have to learn how to read these graphs here. Okay? Switching to Bailey. Bailey doesn't know what Ansley's going to do. Okay? If Ansley decides to study, Bailey has the choice here of studying or not studying. Bailey's going to study. If Ansley doesn't study, all right, if it's one of these two choices, if Ansley doesn't study, Bailey is still better off studying. So Bailey is going to study. So it turns out by using this analysis, we can find out what they're both going to do, which is study. This is called a competitive equilibrium. This is the known outcome that will occur in a competitive environment. This is not always going to happen. You might not have a competitive equilibrium. You may end up with uncertainty, okay? But in this scenario, you can see that it's in both of their individual interests to study. Okay? This is not very interesting, is it? This type of scenario is boring, but I wanted to give you a simple one to start with. What makes it boring is they don't really care what the other one does. So let's look at one that's more complex. So let's move on to an actual game. So you can use this to think about just about any competitive environment can use game theory to think about the choice they should make. Famously, game theory was used back during the Cold War when deciding basically U.S. military tactics in terms of should we have nuclear weapons or not. And game theory is used in lots of different scenarios now. You may have actually, you may be familiar with game theory. You may have seen the movie A Beautiful Mind about John Nash. It turns out he was somebody who, he was basically an economist, and he came up with a lot of the more nuanced avenues of game theory, and he ended up winning a Nobel Prize. So one of his more famous examples is to think about if you're at a bar and you're trying to meet somebody of the opposite sex, should you and all your friends all go to the person that you find most attractive? Probably not. But if you compete, that might be the outcome. So in some scenarios, if you compete, the competitive equilibrium might be that you all go for the same person. But if you're able to organize your behavior, you might realize it's better off if you sort of divide and conquer, so to speak. All right, so let's think about a second scenario here. Choosing the next play in football. All right, this is another good example, I think, of game theory because the choice that you make is based on what you think the competitor is going to do, and you don't know what each other are going to do. So let's use Georgia Tech and UGA. Okay, they're thinking about the choice they're going to make here. Let's say it's first down. And UGA, let's say that they are on offense. Okay, so we know they're really going to do one of two things. If we want to simplify it down to just two choices, they can either pass or they can run. And Georgia Tech basically has two choices as well. They can defend a pass, or they can defend a run. For those of you who watch football, I'm sure you know what I mean here. There's no way to perfectly know what the other team is going to do, but you can set up a defense that is more pass-oriented, or you can set up a defense that is more run-oriented, okay? And you can kind of think about the different outcomes that would occur here. If you're Georgia, what you would like to do is run the play that the defense is not prepared for. So you're going to think about what is the defense likely going to do when you're making your own choice. And let's say that in this case, the numbers that I use are going to be the yards earned, okay? So for example, in this scenario here, do you think there would be a lot of yardage gained by Georgia in this quadrant? So Georgia runs a pass. Georgia Tech plays a defend pass option, so they're going to basically guard all the wide receivers and be prepared for a passing play. In this scenario, what do you think is going to happen? Probably not a big gain. So you might think that Georgia earns 0 yards, and here's the thing. These two answers basically are the inverse of each other. So if Georgia's earning 0, Georgia Tech is also earning 0, so they basically stopped them. Incomplete pass, right? So that's one possibility. Now let's think about this possibility down here. What if UGA runs a pass play and Georgia Tech is all in defending the run? Well, in this scenario, Georgia's probably going to be very successful, right? So Georgia's probably going to have a big gain. Maybe they gain 14 yards. And if you think about this from Georgia Tech's perspective, it's essentially like they're losing 14 yards, right? If Georgia gains 14 yards, it's like Georgia Tech has given up 14 yards here. So this is an outcome that Georgia would love to have, and this is an outcome that Georgia Tech would hate to have, okay? This quadrant up here, UGA earns 8, Georgia Tech -8, and then lastly, this bottom one down here. -2, like that. Okay, so you got these different options here, all right? You should be able to explain each of these options. I probably won't use one like this on the exam because this is more sports economics than it is typical microeconomics, but basically you should be able to explain what's happening here, okay? So why is this quadrant negative for UGA? It's negative because Georgia's running and Georgia Tech's playing a play that defends against the run. This scenario here is going to be very good for Georgia Tech, hence UGA loses yards. So a good play for Georgia Tech. So let's think about strategies here. Remember, a dominant strategy occurs when you make a choice regardless of what the other team decides to do. So you know what you're going to do regardless of what the other team's going to do. Let's see if that occurs. So let's think about it here. From Georgia's perspective, Georgia Tech can do a pass defense, or Georgia Tech could do a run defense. So let's think about these scenarios here. If Georgia Tech does a pass defense here, what would UGA be better off doing? All right? If Georgia Tech does a pass defense, what would Georgia be better off doing? All right, this would be their choices. So Georgia Tech, or rather Georgia, would want to run, and they would thus get 8 yards from that play. Okay? So if Georgia Tech does a pass defense, Georgia should run. Now let's think about the other possibility here. Georgia Tech is defending against the run. What should Georgia do? Well, now Georgia should pass, in which case they would get 14 yards. So it turns out that there is no dominant strategy here. And so it is unknown what Georgia is going to do. Now, if you're thinking to yourself, well, why don't Georgia just do this one? They get 14. 14 is bigger than 8. Why not do this? Well, the problem is, if they do a pass, Georgia Tech might defend the pass. Right? So Georgia can't decide all of these numbers. It can only decide what they're going to do. They can't decide what Georgia Tech is going to do. Okay? So even though 14 is bigger than 8, that really isn't relevant. Okay? The fact that 14 is bigger than 8 might mean that Georgia Tech is more likely to run a pass defense. So it's a complicated decision that Georgia would make. So it turns out that there is no dominant strategy for Georgia. If If you run through this, you should also find that there's no dominant strategy for Georgia Tech. See if you can do that. Pause the video right now and see if you can identify that that's the case. So given all of this information, the result is unknown. There is no competitive equilibrium. We don't know what will occur. Not a super interesting example again, because there's not a whole lot to learn from this, right? All we learn is that it's all chaos, and we don't really know what's going to occur. So starting with the third example now, game theory is really going to shine. This is where we're going to get to see some true insights that are hard to see if you don't use game theory.